the way that the carbon atoms connect within that one sheet of graphene is what gives it the superlative properties that graphene has. It's highly conductive, more conductive than any of the metals that we know of, and it's actually quite strong. By weight, it's actually 200 times stronger than steel. So people are considering use of graphene in composite mixtures with, say, cement for different structural additives. People are adding it to plastics to make their plastics stronger, and if you mix it in the right way, the plastics can actually become electrically conductive.
Wow.
So there are a lot of interesting things going on with making and incorporating graphene into different types of consumer accessible technology.
From Here to the Stars, a video series created by the Tennessee Valley Interstellar Workshop. The TVIW is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. I am your host, Stephen Euin Cobb. Our guest today is Joseph Meany. Joseph Meany is a member of the board of directors of the TVIW. He received his PhD in chemistry from the University of Alabama in 2016, working on nanomolecular circuits, and continues to work on nanomaterial-related research at the Savannah River National Laboratory. He co-authored the 2018 book Graphene with TVIW co-founder Les Johnson, and is actively engaged in independent research projects involving nanomaterials for space applications.
First of all, an obvious question. Do you believe interstellar travel is impossible, inevitable, or somewhere in between?
Well, I'm somebody that believes that it's somewhere in between. Obviously, I would have a hard time being a part of the Tennessee Valley Interstellar Workshop if I believed that it was impossible, but I don't necessarily believe that it's exactly inevitable. There's considerable effort that we have to put into it now in order to put the building blocks all together to allow humanity to go to the stars. Now, that being said, the easier part is to just stop within our own local neighborhood and expand out to some extent within the solar system, maybe out to Pluto or some of the nearer KBOs. But then taking the next leap to cross the ocean in between interstellar systems, that's a bit tougher. You know, one of the analogies could be talking about the explorers who left all of their islands in Oceania, and that's sort of like the solar system, but to then cross the Pacific Ocean was just a tremendous technological and you know, just adventuresome spirit that required some people to really put their lives on the line for you know, a possible impossible payoff. So you know, that required a solid leap of faith, and those leaps of faith I don't think are necessarily something to be taken advantage of, you know, and assume that we'll always have that kind of adventuresome spirit.
Speaking of which, inspiration. How do you feel inspiration will play a part in this? Is it going to need widespread belief in it, or is it just occasional belief, so to speak, or is it like, I mean, it's not really something that just one nation can do, I would think. It takes such resources of energy and money and such. What's your take on inspiration playing a part in it?
Well, that's absolutely true, and maybe we will find it in ourselves to cooperate as a broader species if we really feel that this is a push that needs to happen. But I think also that we're getting to a point where the nation superpowers are actually going to start being capable of developing these technologies. So if, Earth to Moon, Earth to Mars are capable of being achieved routinely by, companies within one nation, so, SpaceX or the Mars generation, those sorts of organizations, if those are things that are achievable by, very distinct groups of people, if a whole population, say, of the United States is really gung-ho, then reaching the outer planets will become achievable in the midterm, and then one can imagine that with the resources of the solar system at our disposal, then it becomes a cooperative environment to reach out beyond the solar system.
Okay. We don't really have anything that you could call space infrastructure built up off the Earth much.
Right.
NASA a few days ago mentioned, or they reported on an asteroid that they said had some number of quintillion dollars worth of metals in it. Mm-hmm. Gold and platinum, iron, aluminum, stuff like that. Which, according to the person writing the magazine article, which I don't know if their numbers were accurate or not, they said that the global economy was worth $75 trillion. So this was way more in this one asteroid. Mm-hmm. Than was the entire economy of the Earth for one whole year.
Okay.
Which probably about fits. I mean, there are thousands of asteroids, really an uncountable number, if you include smaller ones.
Of course.
And they have vast resources. And of course, then there's the moons of outer planets, and then there's the planets, and it's vast. I mean, immense resources. When we mine only a tiny, 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 tiny bit of the Earth's surface. Mm-hmm. And so there's such resources outside of Earth that are more accessible because of the low gravity. It seems like as we build space infrastructure, we will be more able to travel to the stars than we can now. But let me ask you this. Let's see. You wrote a book about graphene with Les Johnson, apparently. Mm-hmm. It's got really astounding qualities. What are some of them?
So graphene is a really interesting material in that it's made entirely out of carbon. And so there are some materials that we know of in our everyday lives that are also made entirely out of carbon. Coal is one of them. Mm-hmm. Diamonds are others. And graphite within pencils is a third version. Mm-hmm. Now to focus in on graphite, if you took a lump of graphite that you found in a mine or something of that nature, or if you took the tip of your pencil, when you rub it in your fingers, what ends up happening is that little sheets of this graphite end up sloughing off and marking your fingers, and that's why we're actually able to write on paper. Mm-hmm. Is that these little sheets slip and slide past one another and deposit onto the paper. Mm-hmm. So these little sheets, if you were to isolate one of them, that's what graphene is. So if you think of a stack of pancakes is graphite, but one single pancake is graphene. Mm. And the way that the carbon atoms connect within that one sheet of graphene is what gives it the superlative properties that graphene has. Mm-hmm. It's highly conductive, more conductive than any of the metals that we know of. And it's actually quite strong. Mm-hmm. By weight, it's actually 200 times stronger than steel. So people are considering use of graphene in composite mixtures with, say, cement for different structural additives. People are adding it to plastics to make their plastics stronger. And if you mix it in the right way, the plastics can actually become electrically conductive. Wow. So there are a lot of interesting things going on with making and incorporating graphene into different types of consumer accessible technology. These days, there are tire companies, including Graphene in the rubber. There are golf ball companies, including it in the plastic shell of the golf ball to make it springier, so you can get that little extra shot. And there are people even looking at incorporating graphene into clothing, so that you can either thermally control and shed heat in the workout clothes, or in like winter clothes, you'll want to be able to pipe some of your core heat out to your extremities, so you'd be able to keep your wrists and fingers nice and warm
Cool.
when you're on the ski slopes.
Okay, very cool. Yeah. You have a PhD in material science, I believe?
Chemistry.
In chemistry?
In chemistry, yeah.
Let's see, what else have I got here?
It just happens to be in a focus of materials science.
Okay.
Yeah.
I'm familiar with the Tennessee Valley Workshop. I'm a volunteer for them. But I'm not that familiar with the Tau Zero Foundation. If you could talk about a little bit about that.
Yeah, so the Tau Zero Foundation is another 501c3, like the Tennessee Valley Interstellar Workshop. But they differ in that the Tau Zero Foundation is actually seeking to organize and fund research projects to push interstellar missions to a more close-based view. And so Jeff Greason, who's here with us at the LibertyCon, is one of the key players in the Tau Zero Foundation. And Mark Millis, who was on the, I believe, third or first episode of From Here to the Stars, he is the founder of the Tau Zero Foundation.
Okay.
And so Jeff and Rhonda Stevenson are the two people really involved with Tau Zero at the moment. I'm an associate of them. I'm one of their subject matter experts, but they're the ones with the real important organizational focus.
Okay. How did you become interested or maybe aware of these two organizations?
So I've always been interested in space. It's been a constant love of mine, sort of from the outside looking in. I'll be the first one to tell you I was so bad at physics in college. Like I could do the algebra-based physics, like that was fine in high school and whatnot. But when I transitioned over into college and I started doing the calculus-based physics, my math just wasn't strong enough to keep up with the rest of my classmates. So I had to reconsider what I was going to do with my life, but I found out that I was actually pretty good at chemistry. So I continued on through undergrad and then eventually graduate school in chemistry, eventually landing in the material science specialty, where I was working on making conducting organic molecules into nanocircuitry for miniaturized components of electronic circuits. So the project that I specifically worked on was actually making a single molecule diode. So I needed to make a molecule that, when it was sandwiched in a circuit, would push electricity forward in one direction and prevent the flow of electricity from going backwards. And I did that in a way that there were two rings of carbon connected together, which are called a biphenyl. They're about a biphenyl molecule is about a single nanometer long. And so the two rings of carbon in the biphenyl were chemically different from one another, such that one ring had a lot of electron density and the second ring had very diminished electron density. So the electronic asymmetry was actually built into the molecule itself, so that when we deposited it on a gold surface, the molecules attached in such a way that they were all oriented in the same direction. And that's really key for the operation of this circuit, because if they were randomly distributed, you're not going to get that one-way behavior that you want. You could think about if you had LEDs just scattered on a tabletop, those aren't going to create the circuit that you want because they're randomly oriented. But if you have the LEDs stuck in your breadboard following the exact same path, then you know that your circuit is going to work the way that you want it to. But I digress.
This reminds me of, I think it was about 2 years ago, I interviewed Dr. Philip, and his goal was to send 1 gram space probes to other stars. You've heard about his project, I'm sure.
Oh, is that Phil Lubin? Right. Lubin out of UC Santa Barbara?
Yeah. His goal was to use an external laser array, direct their laser light at this 1 gram probe, which would for 10 minutes it would accelerate up to 1/4 of the speed of light, I believe, and head off to another star. But then after the next 10 minutes, he would accelerate another one, and then another one, and then another one. So he had this giant cloud heading off in all different directions, and they would do flybys and send the data back with a tiny little diode laser, a laser diode, built onto the chip. And I thought, man, that's great. That sounds awesome. It would still take about 40 years to reach the nearest star because it's only doing about 1/4 of the speed of light. But it would be technically fast, a fast system. What's your take on that? And does this work you're working on, does that somehow relate to that?
Well, the work that I did at Alabama is a little bit off of that. I would be very happy if molecular electronics could get taken up into the physics community and start making actual devices out of it. That would be amazing. And I'm 100%, whoever has some money for that project, I'm on board.
Okay.
But yeah, it's not directly related, but absolutely, it's directly applicable. It's just not a part of the research threads that I'm aware of, at least.
Okay. What's your take on his mission?
Oh, I think it's an absolutely great one, and so...
of course, it's not funded at this point. It's not really, it was just proposed. He wrote a paper, I think it's like 30 pages, on it.
Isn't he a part of the Breakthrough Starshot program?
When I interviewed him, he didn't mention much about the Breakthrough Starshot. That seemed to have come later. That was my take. But yeah, it is associated with it now.
Yeah, I mean, I've paid pretty close attention to it because something I'm working with Tau Zero on right now is a proposal for Breakthrough Starshot using metamaterial enhanced graphene as a potential sail material for this mission. And so what I've been working on is the calculations of different geometries of silicon-based metamaterials in order to maximize the reflectivity, minimize the absorption, and then minimize the mass per area of this particular material.
Do you remember what the reflectivity was, or maybe I should say in reverse, how much was absorbed? Because that's a critical point.
It is, and there's literature published already right now that a silicon-based cubic structure metamaterial can reflect 99.99999% Yeah, 4 nines.
Okay. That's
percent
pretty
of the
good.
light. Yeah.
But is it good enough? I mean, what's the need?
Well,
because so much laser light trained on the object, even a little bit of absorption can vaporize the whole thing.
That's right. So having that 4-9 reflectivity, and actually if you talk about it as a ratio, that's a 6-9 reflectivity. So 1 times 10 to the negative 6th absorption means that okay, you can focus the megawatts onto a sheet of this nature and not have it immediately burst into a million pieces. It's not going to immediately fragment.
Okay.
Graphene is really nice because it's got a very inherently low absorption itself, but its heat distribution is also actually pretty good. So if you have a large enough area, and so the laser, from what I understand of the Breakthrough Starshot, will start out as a small focused spot on the total area of the sail, so that as the beam spreads, it will fill more and more of the sail, with distance.
Okay.
And so if you've got that tiny spot, yes, that'll ultimately end up getting heated first, but if those heat carriers can be conducted away by the graphene exceptionally fast, you don't necessarily have to end up with that kind of overt thermal loading. So, this is all still very much in its infancy. It's still very much in the hypothetical stages. So we are going to continue working on getting funding for this, because the nice part about it is that we can do all of the material modeling in silico, but we can also start producing millimeter square patches of these on just regular natural graphene, and do some of the first metamaterial tests. So you can start doing some of the strength tests, you can start doing some of the binding tests, because one of the open questions that I have is, what is the intermolecular or interatomic structure between the silicon-carbon interface? Does that become carborundum-like? Does that remain graphene-like? That's a really big open question, because what happens to the strength of the graphene sheet as you add this metamaterial is going to be absolutely critical for its performance. So that's actually the first question to answer, is what does that interface look like? What does that do to the strength of the material? From there, does it remain a good candidate to do metamaterial enhanced graphene, or do we have to follow a different line of inquiry?
And is this, in your mind, is this the biggest obstacle, or are there other obstacles even bigger?
Well, there are certainly obstacles even bigger. I mean, right now we do not have a way to reliably produce graphene in a roll-to-roll manner that would be required for large area sheets of graphene. But as I was discussing in a panel last night talking about this technology, people can be working on the large sheet application of graphene, because that's going to be needed pretty much everywhere for graphene to really take off and see more than niche technological use within composites. For what people are predicting, the replacement of silicon in electronic circuits and turning it into wires and that sort of stuff, that's going to need very pure graphene in very controlled sheet manners. So there's a lot of work that remains to be done on that front, but that does not need to halt the fundamental work that needs to go on with actually saying, okay, what happens when we take this nano brick of silicon and put it on the surface of the graphene, and what is that interaction like, and can it actually retain the reflectivity that we need? Can it retain the thermal stability that we need? And does it remain as flexible as we need?
With these kind of energies that are involved, there are nations around the world that fear the possibility of weaponization, that it could be weaponized. What's your thoughts on that? How do we overcome that, or can we?
Well, unfortunately, I don't think that that's something that's going to be easily overcome. You are talking about tremendous amounts of power that, ends up in scary Death Star-like news articles. Because if you start focusing a laser that powerful at the moon, that's going to create some issues for any infrastructure that gets put up on the light side of the moon. The same thing can be said about security for satellites in orbit. And if we start doing shuttling craft between Earth and Mars, lasers that powerful would still remain somewhat of a danger to those. So there's going to have to be a level of trust that we accomplish before one of those, I think, will be allowed to be deployed. That's going to certainly be a considerable political hurdle. Now, it's less of a hurdle because a ground-based laser system can't be turned right back around at the Earth. But that's where a space-based laser array kind of loses a lot of political will, because if you just start turning that right back around at the Earth, and it's already hot enough here in the Southeast. We don't need it any warmer. We're being fried by lasers in space.
Yeah. Yeah, I remember Les Johnson, I interviewed him years ago, like 5 or 10 years ago, and he said that he had been to a conference in Europe, and I believe it was in Italy, but it might not have been. It was in Europe, and they were proposing light sails, and just light sails in Earth orbit, large light sails, because of their ability to reflect light, sunlight. They were afraid of it as a weapon. They were actually terrified of it as a weapon. And it's just, just gossamer thin, but it's big. And so, yeah, I'm thinking that may be something that we have to overcome. Let me ask you a more generic question. Why are telescopes not enough? Why do we have to go, or at least send probes?
Well, I'm sort of the opinion, if we can go, let's go. To sort of bring it back around to the explorer analogy, there's no real substitute for real life going and setting your own 2 feet on the ground. I can look at all the pictures of Alaska that I want, but there's no substitute for actually putting on the snow boots and stepping out on a glacier. And so I think something of that nature where, we can go if the laws of physics allow it, and I think there are an intrepid subset of the population that, because physics allow it, then let's do it.
What about the ethics question of if we're going to colonize, say, centuries in the future, colonize an exoplanet, in order for it to be an exoplanet, it would have oxygen atmosphere, which means that they probably have bacteria, since we believe that our atmosphere was created by bacteria. That is the oxygen in it. So we would be endangering or maybe even wiping out the local bacteria. What are your thoughts about the ethics of that?
Well, that is certainly a difficult question to answer. The sort of off the hip, gunslinger answer is, I would like to try to find a way to understand what life is better in the universe, so that we could better detect potential life forms and avoid planets that are already populated by something else. Leave it alone.
You mean plants and animals?
No, it could be even simple.
Even bacteria?
Yeah, even absolutely bacteria.
Okay.
And maybe if we find evidence of even protobacteria, if we're talking about just self-replicating nucleic acid strains, or of comparable alien information transfer, that's something I think we should allow to develop itself. I mean, I figure if we've got the technology for colonizing an external planet, then why don't we just build a planet out of planetoid materials and assemble it de novo, basically. So why don't we find an asteroid-rich or an asteroid-rich solar system, or even a solar system with a protoplanetary disk, and accelerate that stellar evolution ourselves by self-accreting all of that material and then building that kind of civilization before life has taken hold in its own natural way.
Okay. Yeah. Let me ask you about the Fermi paradox. You're familiar with that, I'm sure. What are your thoughts on that?
Passingly.
Yeah.
I would like to think that there's other life out there to be discovered, and I'd like to, maybe this is my thinking the best of everything optimist kind of viewpoint of the world, but I'd like to find a way for us to learn from another civilization out there without having to engage in violence with them. I know that violence is always a possibility around the corner, and it will always weigh on the minds of other people if we do find another civilization. But I hope that we could find a way to coexist peacefully and trustfully. Now, do I actually believe that there are other systems out there? Well, that's a belief, and I guess I'm a bit too much of a scientist to admit solidly in one camp or another.
Okay. Let me ask you, what is your vision for the long term, say centuries or even maybe a few thousand years? What do you picture humanity as, like on dozens of colonized worlds, or moving toward that direction?
Yeah, I think certainly by that point we'll have tamed interplanetary travel, making a trip out to the outer Jovian planets may only be like a week travel or something of the nature. Doesn't have to be an onerous multi-year, multi-decadal trip. And so once we're able to bring it down to the point where getting from point A to point B in the solar system is like getting from point A to point B on the Earth right now, we'll have a much stronger ability to access the resources that it'll take to get us from here to the local cluster of stars. And so I think once we get outside the local cluster, then it becomes another gulf to cross. As the distances between stars gets larger and larger, then we have to start considering, the actual galactic timescales. And if faster than light travel becomes possible, we're still limited by the speed limit of the universe. Still limited by the speed of light.
Do you believe that we will ever, or maybe I should say, maybe or inevitably or probably develop faster than light travel?
I'm not convinced of anything within current physics that allows the faster than light travel. But what do I know? I'm a chemist, and I couldn't get that.
Okay. Yeah. Okay. So, but you're hopeful?
I am always hopeful. I'm always optimistic.
Okay.
But I do regard it with a healthy dose of skepticism.
Okay.
I didn't finish the story of the how did I get involved with TVIW.
Okay.
That was the digression. But
Okay.
um,
You can add that right now.
yeah. So, but I digress. When I was in graduate school, I was invited to go out to a conference at the NASA JPL for one of their NASA socials, and through a couple of leaps and bounds of a good fortune, I ended up being invited to become a speaker at DragonCon in Atlanta. On the science track, I got to meet the track director and his number two, Stephen Grenade and Rachel Pendergrass. So my first year as a presentation on the DragonCon space track, I was actually talking about nanotech in space. So I gave a lecture there, and Les Johnson's wife, Carol Johnson, comes up to me, and I had no clue who they were at the time. Like, I was just giving a presentation, and some stranger runs up to me and she says, "Oh my God, you need to meet my husband." I was like, "Who are you and who's your husband? Why do I need to meet him?" And she's like, "He's Les Johnson. He's a NASA scientist." And I was like, "Okay, sold." So Les and I talked, and he said, "Oh yeah, you should come out to the Tennessee Valley Interstellar Workshop." And at this point, it was for the 2014 symposium. So I was like, why do you guys want some chemistry graduate student to show up to this space conference? That seems a little bit odd, but I did it anyways, and I've been involved with TVIW as a volunteer ever since, and now I'm on their board of directors. And the vision of TVIW in that they really press hard on involving everybody from not just the engineering disciplines, not even the sciences. They understand the need and desire for all people to get on board for the interstellar vision. And so, as a part of the organization's mission with each of the symposia, we sponsor art shows and we have student scholarships. So it's not just a bunch of stuffy old dudes talking about propulsion methods that have been around since the 60s. It's actual ongoing groundbreaking research coupled with feedback from people in the law community and coupled in the sociology communities, because those are just as valid questions to be answered when you're putting people into a confined space for a long duration of time. And so it was through my involvement with the TVIW that I was also invited to come on board with the Tau Zero Foundation. And so I've been working with them since about 2016.
Okay, excellent. Okay, thanks again for the interview. It's excellent stuff. Yeah.
That was Joseph Meany. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Tennessee Valley Interstellar Workshop, I thank you.